Welcome to Getting to Know Google SecOps. I'm John Stoner, and today we're going to introduce a network function that quickly and easily can focus YARA-L rules on specific net blocks. The network function net.ip-in-range-citer supports both IPv4 and IPv6 addresses. When using the function, we need to provide the UDM field that the IP address is in, as well as the subnetwork range in citer notation, enclosed in quotes. The output of this function is Boolean, that is, true or false. By using this network function within the event section of our rule, we can easily focus a rule on our specific net blocks. Whether your rule is observing traffic originating externally and moving internally, internal to internal, or internal to external, this network function can simplify your rule writing. We often see organizations crafting large regex strings to focus on their rules on specific net block ranges. This function is more performant than using a regex expression within a YARA-L rule, while being simpler to write and troubleshoot. Let's go ahead and take a look. To demonstrate how we can use the network citer function, we're going to build a rule that detects large byte counts from Corelight network connections. In our example, these network connection byte counts will be greater than 1 million bytes sent or received. These byte counts may be a little small for production environments, but hopefully it gives you an idea where we can take this. For those who have been following this video series, you might have noticed that we aren't aggregating our detections because we don't have a match section. Because we are focused on the network function today, we tried to keep our rules simple, but keep in mind that you can have match and outcome sections in this rule as well. Initially, our rule will not care about large connections between systems within our own network. We want to detect large connections when the principal IP address is not in our 10.128.0.0/24 net block, but our target IP is within that net block. Because IP address fields are designated in UDM as repeated, which means they can have multiple values, we are going to exclude any events that have a principal IP that matches our regex by prepending not to our statement. Our target IP criteria is simply that the field equals 10.128.0. This type of notation without the function is perfectly fine, and perhaps for a small network range is sufficient. Let's test our rule and see what we find. Here we can see that we have 3 detections from the same external IP to the same internal IP with sent bytes over 1 million in 2 cases and 65 million in the third case. Let's look at an equivalent statement, but this time we're going to use our network function net.ip-in-range-citer. For the principal IP, we are going to continue by using the not operator and then use our function, and within the parentheses we have our field principal IP with the event variable of $network prepended to it, followed by a comma, and the citer net block we want to compare our field to. Because we have some repeated values in that principal IP field, we've also brought the any statement within our function for evaluation. For the target IP, we've converted it to the same function, and then when we run this rule, we get the same results. Let's change things up here. This time, we're going to look at large byte connections between systems within our 10.128.0.0/24 address space only. We can easily do this by removing the not in front of our principal.ip function. When we test our rule, we get 9 detections. Now, suppose we had portions of our net block where large byte connections were totally fine, but others were a cause of concern. We could carve up our /24 net block and append an OR operator between our functions. In this case, we have a /28 within 10.128.0.0, which will convert our IP range to 10.128.0.0 to 15, and a /29 within 10.128.0.56, which converts to the IPs 10.128.0.56 to 63 that are of interest. Our principal range will continue to be the /24 net block, but with the target being these smaller blocks, we can test our rule and find 3 detections that meet our criteria. While we've just used a small network for our example, Think about how this could be applied to a much wider swath of IP address space within a larger organization. Our example just covered IPv4, but don't forget the same concepts can apply to IPv6 and allow us to focus our rules on specific net blocks. The syntax is very straightforward, but we need both a field to evaluate as well as the CIDR range. Our output will be Boolean, so we don't have an equal sign on the other side of the function, and this function is most often used within the alerts section of a YARA-L rule. If you want to learn more about Google SecOps, check out my blog series called New to Google SecOps for more handy tips. We have a number of community YARA-L detections at our GitHub site and are continually adding more. And don't forget to engage the security community at secopscommunity.com.